In this grade 12 trigonometry question, we are working on proving this identity. So obviously the top part will take that as the left hand side, and then this will take it as the right hand side. So the left hand side, breaking it down should not be too difficult. The only thing is you don't want to do too many things at the same time. Just take it one step at a time. For example, the square root of 2 there, it doesn't look like it's helping anyone, so you can just leave it the way it is. Now the sine x plus 45, right? Clearly that's a compound angle expression, so you may want to open this up using compound angles. There we go. And then sine 90 minus x, we know that 90 minus x is in the first quadrant and everything is positive in the first quadrant. So because we're working with a sine and we're working with a 90, our trig ratio has to change. So the negative here remains, and then here we're going to replace that with cos x. And then here, cos 180 degrees. Remember, if you're dealing with special angles, you can actually just immediately use your calculator and see what answer you get. So for example, this is just going to give us a -1 in your calculator. The reason why it is actually again also giving us a -1 is because a standard cos graph, specifically at -180, your y value there is a -1, but you can get that information from the calculator. So we have there -1, here we have cos x, and then here we just expanded that using our compound angle formulas. So for example, before you multiply the square root of 2 inside your bracket here, you can actually just go to the cos 45 and the sine 45, and then you can change that into a specific number. So let's do that. There we go. So we changed it to 1 over square root of 2 because of our 45-45 triangle. So this being done, what I actually think we can do is to take out the 1 over square root of 2 as a common factor. So if you do that, the 1 over square root of 2 is out, right? And then here you're going to have sine x plus the cos x over there. These two multiplied together, you're just going to have a 1, because the square root of 2 and the square root of 2 there, those are just going to cancel each other out. However, if you put all this in the calculator, you're just going to get a 1 anyways. Okay, so looking at the way things are, I don't even know why I'm putting the brackets, because they're actually just taking us one step further to getting what we have. But it's fine. If you don't have brackets anymore, you can just see that the cos x cancels the cos x. There we go. So the left hand side is definitely equal to the right hand side.